So far, we've covered 2 of the 4 ways of proving triangles congruent, right? The other day we did side, 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 and side, angle, side. Today we're doing the final 2, angle, side, angle, and angle, angle, side. All right? And those are the only 4 that we can use. We can't use angle, 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 just because I could have a triangle like this, like a 30, 60, 90, for example. 30, 60, 90. And I could have one the exact same angles, but they're not congruent. Okay, so I can't use angle, angle, angle. That one doesn't work. And the other one that doesn't work is the bad word. So I'll write it backwards, but side, side, angle. So that's the bad word, so it's bad. It doesn't work. Okay, I cannot have a side congruent to another side and then an angle. It doesn't work out. And you know, if you really want to see how that's derived or why we can prove that, we can do that sometime in class, but we're not going to spend time on that right now. We're going to focus on our angle, side, angle, and angle, angle, side. So first one, angle, side, angle. They have to occur in that order. Angle, then the side, then the angle. So it says of 2 angles and the included side. This means it's in between the angles. In between angles. So for example, in this case, right, I have angle A that's congruent to angle D, and then right in between them, so I'm going to write the angle A is congruent to angle D. Right in between them I have AB and DE, so AB and DE, and then comes the other angles that are congruent. Okay, so you see how the sides in between them, that's where the angle, side, angle comes from. So angle B is congruent to angle E. So if I were to state these 2 triangles congruent in a proof, I would have to have these 3 statements somewhere in that proof, whether they were in the given or I put them in there. And then I'd be allowed to say that these triangles are congruent, like triangle ABC is congruent to, well, A matches up with D, B matches up with E, and then I have F. Okay, so let's take a look at an example here. So I'm going to write my statements and reasons. So I'm going to put S and R. We should be used to that. Put a 1. Right, I'm going to bring my given down. Okay, we should be used to that first step. And remember, we always start by using the given. Okay, so well, first of all, I want to get triangles congruent. So that means I either have to use side, 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 angle, side, or angle, side, angle. One of the 3 that we've done so far. Well, I'm going to use this first part. L is the midpoint of WE. So if L's right in the middle, what do I know? The only thing I can do is set these 2 segments congruent. So that's what I'm going to do. I'm going to say WL is congruent to EL. And we'll say, well, I use that, it's the midpoint, right? L was the midpoint, so we can say definition of a midpoint. All right, now let's use the other part of my given. That WR is parallel to ED. Well, here's WR. ED. Remember, I have to have a transversal to use one of my 4 theorems, right? Our alternate interior, alternate exterior, so on and so forth. Well, I'm just going to pick one of these. So I'm going to go with this guy right here. Okay? And obviously, I'm only looking at, well, I'm not looking at the sides now. If I'm using that sides are parallel, I'm going to look at the angles in the triangle. So can I get any of these angles in the triangle congruent because of those parallel lines? Sure, right here, right? It's inside the parallel on the top side of the transversal, and this guy right here, inside the parallel, and on the bottom side of the transversal. So they're opposite sides of the transversal, inside, so that's alternate interior. So that's what I got. I could set those 2 angles congruent, and I'm allowed to say angle W. To be specific, I'd say angle RWL, but I know what you're talking about with angle W here. Is congruent to angle E. And we just said that's alternate interior angles. And it's really a theorem, so I'm going to put THM to abbreviate theorem. Yep. I'm going to erase all this jazz here so we can see this a little bit better. So far, if you look, and sometimes I like to mark. So far, I got 1 of my congruences, 2 congruences. Remember, we always need 3 congruences, right? I like a side, 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 a side, an angle, side, angle. Go back and mark what I know. I know that these 2 segments are congruent, and I know that these 2 angles are congruent. Well, can I get anything else congruent? I can't do any of the sides, right, because I'm not given enough information. But What do you notice about the angles right in the middle here? These two bad boys are vertical angles, so we can set them congruent. So now I can't just say angle L. I wouldn't know what you're talking about. So I got to say angle like RLW is congruent to angle DLE. Basically, the L just has to be right in the middle. And we just said that they're vertical angles. That's why they're congruent. So vertical angles theorem, or definition of a vertical angle. And there's my third congruent statement. So I should be able to set these triangles congruent. I should be able to say WRL, triangle WRL is congruent to triangle EDL. And then whoop, that's a bad D. I just got to look, well, what do I got? So I'm going to start off with angle W. I got angle, followed by side, followed by angle. So angle, side, angle. ASA. So there we go. So anytime you have triangles congruent, it's got to be one of our 4 things. And so far we've done 3. Side, 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 angle, side, angle, side, angle. And just look at what you prove congruent. So obviously our other one is angle, angle, side. So really, they just have to go in order. Or I mean, it could be side, angle, angle. But we just use angle, angle, side. Or you can flip-flop them. Either way is fine. But if you take a look, like angle C is congruent to angle F. The side in between them is not. But the very next angle over, B and E are congruent, and then the side right after that. So that's where I get the angle, followed by the angle, followed by the side. So angle, angle, side. And let's use that in a proof here. So I got angle NKL. I'm going to go mark that. Angle NKL. So that means that's up here. And then angle NJM. So NJM. So that one right there. Okay, so I'm going to go mark those again here. So those two are congruent. And I got KL is congruent to JM. So KL, which is like this guy, is congruent to JM, which is this guy. So if we're looking at this, I want to prove that LN is congruent to NM. So I want to get these two congruent. Well, before I can get those congruent, what do I have to do with these triangles? Right? We got to get them congruent. So basically, I got to get this triangle, because I'm dealing with this side, right? That's what I'm trying to prove. And I'm dealing with this triangle. And I got to get them congruent first. Okay, so let's just go back a second here. I'm going to make my markings. So we just had NKL and NJM, and then these two sides. Okay, so let's set up my proof. And we got statements and reasons, and 1, bring my givens down. 1 given. Well, if you take a look, I might already have 2 of my congruent statements. Well, that's not even a word. Statements. I don't know why I like to do that. Anywho, so I should just try to get my third statement. Well, can I set any of the other sides congruent? Like, can I get NK congruent to JN? I don't think so. I'm trying to prove the other sides, right? I'm trying to prove that LN is congruent to NM, or MN. So I can't get those congruent. What about our angles? What are the other angles of the triangle? Well, we got these two guys, but I can't set them congruent. I don't know. I don't know what those are. Well, notice they share an angle right here. If they share that, isn't that angle congruent to itself then? Because like the angle N on the one triangle and the angle N on the other triangle. So I can set something congruent to itself, and we have a property for that we learned a few chapters ago. It's called the reflexive property. So reflexive. Okay, so you do that quite often. If you can set a side or an angle congruent to itself, that should help you. Well, then let's take a look at these triangles. Am I able to set these triangles congruent? Let's see what order we got. We got angle. I'm just going to look at this triangle right here for now. So angle, followed by an angle, followed by the side. So that's angle, angle, side. And this is my third congruent. So I should be able to set them congruent. So make sure the vertices match up. So I'm going to name that first triangle. I'm going to go JNM. JNM. You can name whatever you want, but then it'll affect your second statement here. So if I say JNM, I better go KNL. So triangle KNL. And that would be what I just said. Angle followed by an angle followed by a side. So I got to get those triangles congruent in order to set the segments congruent. And what was our reasoning that we learned the other day? anytime I'm trying to get like a segment or an angle congruent, or for what I'm trying to prove, and I have triangles, we always get the triangles congruent first, which we just did. And then we can state these because I know that every single side and every single angle are congruent on congruent triangles. So what's our little acronym for that? Remember, CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so you always use that in triangle proofs when you're trying to prove sides or angles congruent. And once you do a few, you get used to that, and it just comes naturally. So lastly, just covering them all, remember we have side, side, side. We have side, angle, side. We have angle, side, angle, and angle, angle, side. So basically just know that if I'm going to use side, 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 I should have 3 congruent segments in my proof somewhere. If I'm going to use side, angle, side, I should have 2 congruent segments and 1 congruent angles, 1 set of congruent angles. Okay, so on and so forth. So here I'd have 2 congruent segments. Oh, I lied. 1 congruent segments and 2 sets of congruent angles. And lastly, we would have same thing, except this just matters on the order, right? Depending on the order that they come in. So same thing, 1 congruent segment and 2 congruent angles. And that's all you need to know for triangle congruent proofs.